So I welcome you all in the third lecture of the Biosynthetic Pathways series. So in this lecture we are going to see shikimic acid pathway in detail. So far we have covered this point, that is the how these secondary metabolites are produced by using different type of pathways, and we will focus upon this shikimic acid pathway in this lecture. So let's start. So shikimic acid, basically it is a key intermediate from carbohydrates, and it is used for the biosynthesis of these units, that is C6 3 units, and they are known as the phenylpropane derivatives, and it serves as a precursor for the biosynthesis of amino acid. Okay, and then it's also as an intermediate in the production of tannins, flavones, coumarins and vanillin. Let's see here, via shikimic acid we produce this aromatic amino acid, which then produce different type of secondary metabolites, like here in this case alkaloids, and over here we have tannins and flavonoids, lignins, vanillin, etc. So what are the various steps involved in this pathway? That is the first of all, we have a phosphenol pyruvic. This is a reaction that you have to remember, and you have to draw the structures also in the examination. So phosphenol pyruvic acid is there. This is the structure of the phosphenol pyruvic acid. As you can see, this is the simple structure of the pyruvic acid. So if you add the phosphate group, it becomes phosphenol pyruvic acid. That is, this is the phosphate group, that is the H2PO3, and here it is C again, COH, CS2, and here it is connected by this O, that is oxygen. Just look at again. So COOH is there, and COH and COCS3 is there in the pyruvic acid. Here you can see COH and CO, then apart from CS3 it becomes CS2. So this is the phosphenol pyruvic acid. Here erythrose 4 phosphate is there. So when it combined, to look at this, this is the erythrose, there is a common sugar, and it is attached with this phosphate, it becomes erythrose 4 phosphate. So I will show the structure of erythrose also, that is a sugar. Just see, this is the structure of this sugar, that is the erythrose sugar. So this phosphate group is attached, so it becomes, that is C, here it is CHO, CHOH, H and O, here again H and O, here it is the phosphate group, that is H2PO3 group is attached. So when these two combines, what happen? Here you can count 1, 2, 3. 3 carbon is there. Here 1, 2, 3, 4. So it means 7. That means a heptonic compound is produced. So this is again 1, 2, 3, 4, 5, 6, 7. So this compound is produced, that is nothing but 2 keto 3 deoxy 7 phosphoglucoheptonic acid. See again what happened here. So shikimic acid pathway starts with the erythrose 4 phosphate, that is obtained by pentose phosphate pathway, and phosphenol pyruvate, which is obtained by glycolysis. So this is produced through pentose phosphate pathway, and phosphenol pyruvic acid produced via glycolysis, and upon aldol condensation it will yield this compound. You will remember the short form DHAP, that is 2 keto 3 deoxy D arabinoheptonic acid, basically, or you can say the heptonic acid 7 phosphate. So this reaction is done by aldol condensation, and I hope you remember about the aldol condensation, what is happening in the aldol condensation. In this aldol condensation, what was happening? So, or it is a reaction in which basically the enolate ion, it reacts with the carbonyl compound to form this compound. You have to remember this one, that is beta hydroxy ketone, or beta hydroxy aldehyde derivatives are produced by aldol condensation. So when this hydroxy, you can say this keto deoxy heptonic acid is produced, then what happen? What is the next step? Here it is written, it will convert into 3-dehydroquinic acid and then 3-dehydroshikimic acid. Let's see how. So what was happen here? This compound, that is the DHAP, upon removal of the phosphoric acid, it again cyclizes, it rearranges itself to form this 3-dehydroquinic acid, and which on dehydration form 3-dehydroquinone shikmic acid. See, it removal of the phosphoric group, what happened here? Removal of this group, and it cyclizes in such a way that it forms dihydroquinic acid. And if you look carefully, what is the difference between these two structure, dihydroquinic acid and dihydroshikmic acid? The only difference between the two is of here. So what is the reaction here? Is nothing but dehydration. And we know what is dehydration reaction in chemistry. It is simply the loss of the water. And after that, what was happening? It yields shikmic acid by reduction. Just see here, 3-dehydroquinic acid formed by dehydration. Okay, it is removed, it formed dihydroshikmic acid, and then with the reduction it forms shikmic acid. Look at this, COH, here it is OH and double bond O. And what is the structure of shikmic acid here? Again COH, here it is OH and OH. Look at this. So again, and I hope you know about the oxidation reduction reaction. If we talk about the oxidation reduction reaction with respect to the oxygen, we can say that oxygen is the gain of, that is, the oxidation is the gain of oxygen, where reduction is the loss of oxygen. But if we talk about with respect to the hydrogen and we focus on the reduction here, the reduction means the gain of the hydrogen. And you will see here what was happening here. From dihydroshikmic acid, this shikmic acid produced, and here again double bond OH. Then what happened? Yes, reduction is there, hydrogen is added. Then the next step is the shikmic acid is produced, we know. Then it will undergo, shikmic acid undergo phosphorylation and elimination reaction. So shikmic acid will undergo phosphorylation and elimination reaction and form an intermediate that is known as the corysmic acid. Corysmic acid is produced by phosphorylation and elimination reaction. And we know what is phosphorylation? Attachment of the phosphoryl group. Just see here, if we talk about from the shikmic acid, this corysmic acid is produced by phosphorylation and elimination reaction. And this acid, that is the corysmic acid, or you can say corysmic acid, is an important element for this production of the anthranylic acid. And this anthranylic acid, it resulted in the production of this aromatic amino acid, that is the tryptophan. So first aromatic amino acid is produced by shikmic acid pathway. Just see here, from this corysmic acid, anthranylic acid is produced, and this will serve as a precursor for the production of this tryptophan. And this tryptophan is nothing but it is an aromatic, because it has aromatic ring, amino acid is there. So it is an aromatic amino acid, and from this aromatic amino acid we will produce different type of metabolites. There is another path, that is, you can see here, from corysmic acid, then prephenic acid is produced, and it will result into the production of again phenylalanine and tyrosine. So these two again, these are aromatic amino acid, and from this aromatic amino acid there are different type of metabolites are produced. Okay, so what was happening, this corysmic acid, it via rearrangement it will give prephenic acid. So here reaction is the rearrangement reaction, and this will produce, that is the prephenic acid. And this prephenic acid, upon dehydration and decarboxylation, it will yield phenylalanine. So it will produce phenylalanine by dehydration and decarboxylation. And here you can see, on dehydrogenation and decarboxylation, this prephenic acid yield beta hydroxyphenyl pyruvic acid, which is a direct precursor of the tyrosine. Here via dehydrogenation and decarboxylation, this tyrosine is produced here from prephenic acid. So this prephenic acid resulted into formation of two aromatic amino acid. First is the phenylalanine, second is the tyrosine. So I think we are short of time to watch. I request you to watch the next part for the better clarity. Thank you for your patience and listening.